Hello, this is your lecture video for section 6.1, ratios. A ratio is when we compare two quantities, and the order that we write them in is important. So if we're saying the ratio of A to B, that can be written three different ways. It can be written with the word TO2, or with a colon, or as a fraction, and we'll stick with a fraction for our section. It's important to know that B cannot be zero. That second number cannot be zero because remember that we've learned before we cannot divide by zero. And so that would make an undefined expression. For example, at a local charity event, there were 11 male volunteers and 27 female volunteers. Using all three notations, write the following, the ratio. I'm going to have us just stick with this notation. That's the one that we're going to see come up the most in a math course. So the ratio of male to female, the number of males is 11, the number of females is 27. So we're going to say 11 over 27. If I were to switch those numbers, just notice that's a completely different fraction. That would actually be the number of females over the number of males. So that's a different comparison. So the order that the words come in makes a difference in how you write the fraction. So this one, again, that's not correct. The ratio of female to male volunteers, well, we just talked through that one. That would be the reciprocal of the fraction because we switched the order of the words. The ratio of male volunteers to the total number of volunteers. So the number of male volunteers is 11, but to get the total, we would need to add our two parts. So 11 and 27 would be 38. So 11 to 38. Another example, if there are 52 cars in a parking lot and 21 are silver, write a ratio and fraction form for the following. Write the ratio of the number of silver cars to the total number of cars. So silver is 21. The total is 52. We were given both of those numbers in the original sentence. Write a ratio of the number of silver cars to the number of cars that are not silver. So we know there are 21 silver. To get the number of cars that are not silver, if we just take the total and subtract the ones that are silver, we would get the rest of them that are not silver. Simplified ratios. In a statistics course, there are 25 male, 75 female students enrolled. We see that the ratio of 25 to 75 is referring to the actual number of students, but ratios are typically expressed in a simplified form. So if we take that fraction 25 over 75, which is an accurate ratio, but it can be simplified. So if we reduce, both of these are divisible by a 25. So this would, let me just make this a little bigger. This would reduce to 1/3. So 25 over 75 is the same value as 1/3. 1/3 is just the simplified form of it. We can then write the ratio in simplified form using the three notations. Again, I'm going to have you just do that one notation. How would you interpret this simplified ratio? So if we say 1 to 3, and what we were talking about again is the number of males compared to females. Does that mean that there is just one male and 3 females in this statistics course? No. Keep in mind that 1/3 is equivalent to a lot of different fractions. So I'm going to take this numerator and denominator and multiply top and bottom. So here I'm multiplying by 2. Remember, that's a form of 1. If I multiply it by 3, if I multiply it by 4, all of these are equivalent fractions to 1/3. If we multiply by 5, if I multiply by 25, notice that 1/3, it's the same thing as all of these, and here's our original fraction. If we kept building it up, we would get to 25 over 75. So how do we interpret the simplified ratio? It doesn't mean that there's one male and 3 females. It means that for every one male, there are 3 females, and that might be that there's 2 males and 6 females in the class, or 5 males and 15 females in the class, or 25 males and 75 females. When we're given just this reduced simplified ratio, we don't know which one of these we're working with, because we aren't told that information in this particular case. Coach Jim Sachs gave a physical fitness test to his PE class. There were 10 students that did not pass the test and 35 students who did pass the test. Write the simplified ratio of those who did not pass to those that did pass. Sometimes words are helpful just for me, so that I remember which number I'm putting where. So they're asking for did not pass compared to those that did pass, and the order we put these things in matters. So I'm just going to give myself a reminder there. Did not is the first number, did is the second one. And again, I'm just going to use that one notation. So did not pass, I'm just going to go back up here and read. That's 10 students that didn't pass, 35 that did. So did not pass is 10. Students that did pass is 35. And then we'll simplify that. These are both divisible by 5. So this would simplify to 2/7. Interpreting the results means for every 2 students that did not pass, 7 of them did. Using fractional notation, write the ratio in lowest terms for the following. 10 pounds to 14 pounds. I'm going to take this and stick it in fraction form. So 10 to 14, just reducing the fraction. These are both divisible by 2. So this would reduce to 5/7. 21 days to 30 days. These are both divisible by 3. So that would simplify to 7/10. Applications of ratios. In 1981, a giant sinkhole in Winter Park, Florida, swallowed a home, a public pool, and a car dealership, including 5 Porsches. That is a big sinkhole. One witness said that in a single day, the hole widened from 5 feet in diameter to 320 feet. Diameter is the distance across the circle, so that's a lot of widening of the sinkhole. Find the increase. So from 5 to 320, how much of an increase is that? We're just calculating what's the difference between those numbers. So that's an increase of 315 feet. Write a ratio representing the increase to the original. So the increase is 315 compared to the original of 5. And let's simplify this. These are both divisible by 5. 315 divided by 5, 63. And this is the same thing. 63/1 is just 63. However, when we're writing a ratio, we want to see 2 numbers. If we were just given the 63, we would know that is the same thing as 63/1. But this, I would actually leave it like that. Okay, we're done. I'll point out a couple more things. In some of these examples, we used part to part comparison. Sometimes we did a part to a whole. Sometimes we did the whole thing compared to a part. And it's just good to think about ratios in this way so you can recognize a little bit better what numbers you're working with. So if an example, we make up another one. If there are 3 males and 7 females, are those parts or totals? Those would both be parts. If the question asks, write a ratio that compares the number of females to the total, keep in mind what we were given were parts, but now we're asked about total. So we have to do a little computation to get the total. So sometimes you're going to be asked about a number for example, 10 that you're not given in the problem, but you'll know how to get it if you read carefully. So take your time when you're reading these. Make sure that you are um, representing what they're asking for in representing numerically what they're asking for in words. Okay, and that is your